Okay, so this one is we're gonna solve a systems, and we're gonna do this by graphing. And this is where you guys need to use your lovely little friend, which is called Desmos.com. So you're gonna graph equations, and you're not gonna you don't have to solve algebraically because you can just use Desmos.com, because this is that class. What are you gonna do that's real life applicable? Well, that's gonna be Desmos.com, because you're gonna always have it. It's in your back pocket, called your phone, because you've downloaded that app. It's totally free. So this is where you're going to graph, and what you're looking for is where two lines are going to intersect. So you're going to solve that by graphing. And so if I just look at this, I'm going to say, oh, well, that x value between 40 and 60 is 50. And then that y value is 5. So that's my point. So remember that when you're writing a solution point, it's always x and then y. So it's always x and then y. So the next is we've got some information and we've got some data, and we're going to have two sets of data. So there's a school fundraiser. They're selling flowers during lunch. The club found two companies, and there's the roses are red. So those roses are red, and which is a flat rate at $20. So at $20, and then additional 75 cents a flower. So all of this data, all of this is already done for you. It's already put in. So we're going to go ahead and we're going to graph that data. So my y-intercept is at 20, and then when x is 40, when I have 40, I'm at $50. And remember here, I'm counting my tens. So 10, 20, 30, 40, 50. And you're just going to graph those dots for me. So go through and do that. And you're going to follow along, and you're going to graph all those dots. Okay, so I went through and I graphed the roses are red data, and notice that I can't do the 200 because it goes off the chart at 170, and I cannot graph the 240 because my graph doesn't go all the way up. So I just graphed all of the points that I could definitely graph. The next one is the flower power. So with flower power, now that start amount is going to be a little different. So with flower power, that start, I'm just going to use a different color. So flower power, I'm using green. So flower power, that y-intercept is at 60, and then I'm going to go through and graph those dots. So at 40, I'm at 80. And then at 80, I'm going to go up to 100. And then at 120, oh, they're the same. And then at 160, so at 160, and you're going to go through and you're going to keep graphing all of your data. So go through and do. And I was mistaken. It is not at 120. It's not at 120 when they are the same. It's going to be at 140. They're going to be the same. Or at 160, they're the same when both things are at 140. So I'm going to draw a line kind of to show more of just my point. So I'm going to go through and I'm going to draw a nice straight line because it's helpful if you have nice straight lines. The cool thing is that you guys have Desmos.com. Remember, I'm 50. I never got to use cool stuff like that. Neither did your parents when they went through and did this. So you're going to go through and you're going to graph. Now, if you look after that intersection point, roses are red cost more money. So after that intersection point, roses are red is going to cost more money. And then flower power will be cheaper after that intersection point. So this is that real life example of when does it actually pay and what are you really wanting. So if you look at the table, it doesn't matter what company you'll use. So what they're saying with that, so I go through and I'm going to highlight when does that actually matter, because that would be the same. So right there, they're exactly the same. So this question right here is saying, oh, so looking at the table, when will it not matter which company? So when you buy 160 flowers, because the price is the same. All right, so that's the reason why. And then when is it cheaper to use roses or red? And I'm gonna make this a little smaller. So when is it cheaper to use that roses or red? Well, roses or red, remember, is my little green, is my reddish pinkish line. So that would be cheaper when it's if you're gonna sell less than 160 flowers. That's when it's going to be cheaper. And then the next one, when will it be cheaper for flower power? So flower power is our green one. And if we look at this, flower power is less than the roses are red. So that's going to be less. So then that's when you're going to sell more than 160 flowers. So this is kind of like after writing equations of the two, and now after writing equations of the two equations, you're going to have to solve algebraically. Okay, algebraically, I'm not going to worry about that because we just found it. So roses, after writing the equations of the two situations, solve algebraically. Well, we both know that the answer is going to be 140 flowers, or 160 flowers is going to be your cost. Because that's where you're going to have it, 160 flowers. 160 flowers. And so basically, and then you can go through because you're going to have, because this would have been 20 plus 0.75x equals y, and then this would be 60 plus 0.50x equals y. And so when they're asking you to do this, is that you're going to have 20 is equal to 0.75x equals 60 plus 0.5x. I should probably make it so you can actually see. And so basically I put, this is your roses are red equation, this is your flower power equation, and then since they're both equal to y, you set them equal to each other. And then this, instead of, I move the smallest one of my x values, and since this, this is a plus, I don't know why I put equals. Since this is 0.5, that's smaller, I'm going to move the 0.5x. And the reason why I move the smaller is because I don't like to have to make mistakes with negatives. So that cancels out. 0.5, so 75 cents minus 50 cents is 25 cents. And this still equals 60. And then that's 20. Then I'm going to subtract 20. I'm going to subtract 20. I'm writing really small because I'm running out of room. And I'm running out of room. I got to move it. So 20 divided by 20, 20 minus 20 is 0. So you got 25 cents times x equals 60 minus 20. So 60 minus 20 ends up being 40. And then you divide by your 25 cents. So x is equal to, and you use your lovely little friend. So 40 divided by 0.25 ends up being 160. This is why that worked. So this happens to be why it worked, and so you're going to have 160 flowers. That's the reason how come that's where they would actually equal each other. So that would be if you're solving algebraically. I'm not asking you to do that because this is real life. And let's face it, this is the real life math class. You're going to use your friend, which is Desmos, and because in real life you're going to figure that out, and you're going to probably not run to algebra because most people are not like me and do all this algebra to do things.